Yes, good morning, one and all. Yes, hope you all doing good. Yes, fine. Last video we discussed about the lone pair of a molecule and which does not have the lone pair. Okay. Yes, in this now we are discussing about the valency bond theory. This valency bond theory was introduced by the Hitler and London in 1927. Okay, they developed after Pauling, they developed the valency bond theory. Why they developed the valency bond theory? This is the first thing we should discuss. Why they developed the valency bond theory? Yes, because there is a limitation for the Lewis dot structure and the VSEPR theory. VSEPR theory and the Lewis dot structure or Lewis approaches, any Lewis approaches which have the limitations. When it comes to the limitations, the VSPR only it is applicable to the diatomic molecules. VSPR, that is VSEPR theory applicable to diatomic molecule. Okay, it is applicable to diatomic molecule and it fails to explain the give the simple explanation about heavier molecule. This is the limitations. ಸಿಂಪಲ್ ಆಗಿರುವಂಥ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಇದೆಲ್ಲ ಅಪ್ಲಿಕೇಬಲ್ ಆಗೋದು ಡೈಅಟಾಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ಗೆ ಅಪ್ಲೈ ಆಗೋದು ಮತ್ತು ಹೆವಿಯರ್ ಮಾಲಿಕ್ಯೂಲ್ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದಕ್ಕೆ ಫೇಲ್ ಆಗೋದು. ಇಟ್ ಫೇಲ್ಸ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ಸ್ ದ ಹೆವಿಯರ್ ಮಾಲಿಕ್ಯೂಲ್. ಇಸ್ ಕ್ಲಿಯರ್? ಎಸ್. ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ಟು ದ Lewis approaches. When it comes to the Lewis approaches ಬಂದಾಗ ಏನಾಯಿತು, ಓನ್ಲಿ it gives about the how to draw the structure. ಹೇಗೆ ಸ್ಟ್ರಕ್ಚರ್ ಡ್ರಾ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ, ವಿಚ್ ಮೀನ್ಸ್ ದ ಆಕ್ಟೇಟ್ ಸ್ಟ್ರಕ್ಚರ್ using the dot electrons, how to draw the octet structure, but it fails to explain the bond formation. Between the atoms, how the bond will forms, whether it is a sigma bond. These all things it fails to explain. This is why both the theories fails. So new theory, which is valency bond theory, which is proposed by Hitler and London in 1927. What it says about the new valency bond theory? What are the things? For example, I am taking just assume that is the H2. H2 is the molecule which have the atom HA and HB. ಅಂದರೆ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಹೆಚ್ ಅನ್ನೋ ತೋತಾ ಇದ್ದೀವಿ, ಅದರಲ್ಲಿ HA HB ಅನ್ನೋ ಆಟಮ್ಸ್ ಇದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಅಸ್ಯೂಮ್ ದಟ್ if it is the HA, then in a center we know that each atom have in a center there is a nucleus, and in the surrounding which have the electron, right? This is how we are assuming. There is a center, there is a nucleus. In that nucleus we can write Na. Is it clear? HA atom ಆಗಿರೋದ್ರಿಂದ ನ್ಯೂಕ್ಲಿಯಸ್ ಏನಾಯಿತು, Na ಆಗಿದೆ. Is it clear? And the electron become Ea. ಏನಾಯಿತು, HA ಆಗಿರೋದ್ರಿಂದ ಆಟಮು ನ್ಯೂಕ್ಲಿಯಸ್ Na ಆಯಿತು and electron became the Ea. Is it clear? For HA and HB I am writing here, then we know that nucleus means which have the positive charge, that is Na. Positive charge I am writing about that, and Nb. If for the atom HB, that is the Nb, nucleus Nb ಆಗಿರುತ್ತೆ. Is it clear? This is the nucleus which consists of proton and the neutron which is the zero value and the proton have the plus. Is it clear? And ಅದಕ್ಕಿರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗಿರುತ್ತೆ, HA ಆಟಮ್ಗೆ ಎಲೆಕ್ಟ್ರಾನು EA ಆಗಿರುತ್ತೆ, HB ಆಟಮ್ಗೆ ಎಲೆಕ್ಟ್ರಾನು EB ಆಗಿರುತ್ತೆ. This or we call it as a electrons. Is it clear? This is how. As we know that why we are writing that we are took the example of hydrogen, the hydrogen molecule, and we can consider as a two different atoms, and in the two different atom different nucleus and different electrons. This are why we are discussing this means here there is a, when we are discussing the valency bond theory, there is a attractive force and repulsive force. In electrons ಅಂದಾಗ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ನ ಕ್ಯಾರಿ ಮಾಡುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂದಾಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕ್ಯಾರಿ ಮಾಡುತ್ತೆ. ದೇರ್ ಈಸ್ ಎ like charges and unlike charges. We discussed this in a previous classes also. Like charges, as we know, like charges what happens? Yes, like charges repulse, and unlike charges which attracts. Yes, unlike charges which will attract. Okay, what is about this attractive force and repulsive force? ಹಾಗಿದ್ರೆ ಈ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಅಂದ್ರೇನು, ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಏನು? ಫೋರ್ಸ್ ಆಫ್ attraction and force of repulsion, we will say that is the force of attraction. Yes, first one, that attractive forces, how it arises, that is the attractive forces. When we are discussing the attractive forces, as we know that the nucleus of one atom Na, and electrons of the own atom Ea, and Nb and EB, which is the attractive force. Normal ಆಗಿ attractive force ಆಗುವಂಥ ಚಾನ್ಸಸ್ ಇರುವಂಥದ್ದು ಇದು. And one more chances are there, that is the Na which will attract with Nb, and Nb attract with Ea. This is how come it's way. I will explain you. Yes, if you see here, you can see that I wrote the Na and Nb, the two hydrogen, that is the hydrogen atoms. That is one of the hydrogen, that is Ha, and another hydrogen, that is Hb. Okay, this is how the hydrogen molecule I wrote. For the attractive force, I told you already, I told you how the formation, the nucleus ಇದ್ದಾಗ ಅದ್ರದ್ದು electrons ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅಂತ. See here, I wrote the nucleus, next to that I wrote the electrons, because which have the high attraction, the opposite charges which have the high attraction. And here I wrote the second atom, B atom ಗೆ ಬರ್ದೀನಿ nucleus and the electrons which have the high attraction. The same atom, the nuclei of one atom which have the same atoms to electron formation ಆಗುವಂಥದ್ದು ನಾನು ಬರೆದಿದ್ದು first one. And the nucleus of one atom and the electron of other atom, the nucleus of one atom, see here, from here to here. So I wrote in a ಡಾರ್ಕ್ ಲೈನ್, ದಟ್ ಈಸ್ ಯಾವ ರೀತಿ ಸೆಕೆಂಡ್ ಫಾರ್ಮೇಷನ್, ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ಸು ಮತ್ತೊಂದ್ರದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಜೊತೆ ಫಾರ್ಮೇಷನ್ ಆಗುವಂಥದ್ದು. ದಟ್ ಈಸ್ ಹೌ ದ ಫಾರ್ಮೇಷನ್. ದಿಸ್ ಈಸ್ ದ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್, ಹೌ ಇಟ್ ಫಾರ್ಮ್ಸ್. ಅರ್ಥ ಆಗ್ತಿದೆ ಅನ್ಕೋತೀನಿ. ಎಸ್, ನ್ಯೂಕ್ಲಿಯಸ್, ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ಸು ಅದರದೇ ಎಲೆಕ್ಟ್ರಾನ್ ಜೊತೆ ಆಗುವಂಥದ್ದನ್ನ, ಆಪೋಸಿಟ್ ಚಾರ್ಜ್ ಆಗಿರೋದ್ರಿಂದ ಅದು ಸೇಮ್ ಆಗಿರುತ್ತೆ, ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಆಗಿರುತ್ತೆ. ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ಸು ಮತ್ತೊಂದ್ರದ್ದು ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದು ಆಪೋಸಿಟ್ ಚಾರ್ಜ್ ಆಗಿರೋದ್ರಿಂದ ಅದು ಅಟ್ರಾಕ್ಷನ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ ರಿಪಲ್ಷನ್ ಆಗಬೇಕಾದ್ರೂ ಅಷ್ಟೇ. ಯಾವ ರೀತಿ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ ಅಂದರೆ, ಆ್ಯಸ್ ವಿ ನೋ, ಇಲ್ಲೇ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ನು ಹಾಗೆ ಹೇಳ್ಬಿಡ್ತೀನಿ. ಸಿ ಹಿಯರ್, ಆ್ಯಸ್ ವಿ ನೋ, ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಯಾವ ರೀತಿ ನಾರ್ಮಲಿ ಆಗುತ್ತೆ ಅಂದರೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಫ್ Ea and electrons of B, Eb, which will repulse, and the nucleus of Ha and nucleus of Hb, which will repulse us. This is how there is a repulsive force. Attractive force ತಗೊಂಡಾಗ two atoms close ಆಗಿರುತ್ತೆ, which tends to attracts. ಏನು, ಆಟಮ್ಸು ಕ್ಲೋಸ್ ಆಗಿದ್ದಾಗ ನ್ಯೂಕ್ಲಿಯಸ್ಸು ಮತ್ತು ಎಲೆಕ್ಟ್ರಾನು ಅಟ್ರ್ಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಅಟ್ ದ ಸೇಮ್ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಬಂದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಪಲ್ಸ್ ಆಗುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ರಿಪಲ್ಸ್ ಆಗುತ್ತೆ. ದಿಸ್ ಈಸ್ ಹೌ ವಿ ಕ್ಯಾನ್ ಡಿಸ್ಕಸ್ ಇನ್ ದ repulsive force. I will write you repulsive force. what are the two forms we can see? That is, the first one is, that is EAEB, that is EAEB formation, and next we can see the nucleus, that is NANB. These are the repulsive forces formation ಆಗುವಂಥ repulsive force. Is it clear? Yes. Yes, as we discussed about the bond enthalpy, bond length, these all things we discussed in last classes also about the bond enthalpy. Bond enthalpy is the energy which is releases. Now, how much energy which is required or releases, that is the bond enthalpy, and it depends on the bond length. Depends on the bond length. ನಾವು ಅದನ್ನ ಹೇಳಿದ್ವಿ, H2 ಮತ್ತು F2 ಅಲ್ಲಿರುವಂಥ ಬಾಂಡ್ ಲೆಂತ್ ಡಿಫ್ರೆನ್ಸ್ ಯಾಕೆ ಇರುತ್ತೆ, ವೆದರ್ ಇಟ್ ಈಸ್ ದ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಆಲ್ಸೋ ವಿಚ್ ಹ್ಯಾವ್ ದ ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ಈಸ್ ಡಿಫ್ರೆಂಟ್, ದಟ್ ಈಸ್ ದ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ವಿಚ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್, which needs the energy to needs the breaking of the bond is different for the hydrogen and fluorine. That is, hydrogen and hydrogen, the bond length is 74 picometer. Bond length is 74 picometer, and which needs the bond dissociation enthalpy is 435.4 minus kilojoule energy is required, whereas fluorine, which also have the single bond, okay, single bond, which the bond length is 124 picometer, and which needs the 2 Farad of energy to break. Is it clear? This is how we can why this is what the major thing fails in the Lewis approaches ಅಲ್ಲಿ ಫೇಲ್ ಆಗಿದೆ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ದು ಅಂತ ಹೇಳಿದ್ದು ಇದು ಒಂದು ಕಾರಣ ಇರುತ್ತೆ. So why I am discussing this here means I will show you the bond enthalpy, how the bond enthalpy we will discuss. That is, if the graphical representation, I will show you the graphical representation.